Here's a cool math thing I made. It's a sculpture I call Spaghetti Code. It's hanging in the lobby of the Computer Science Building at Stony Brook University in New York. I designed it to be built as a sculpture barn raising. I wanted lots of people to help me put it together. About 200 people came from all over campus and helped me put it together in about 2 or 3 hours in one day in December of 2004. I began by explaining how the parts go together. There are 180 laser-cut aluminum pieces. They have tabs at the ends and slots for the tabs to go through. Technically that's called a mortise and tenon joint, with a hole for a pin that locks it together. Everyone began by taking 3 pieces. The first shape of piece goes together, 3 of them, to make a triangle. It's a little bit tricky because the laser cutter cuts directly orthogonal to the surface, so wherever 2 pieces join, they actually meet at right angles, and yet we're able to make a triangle. The idea is that the pieces lie in planes that are orthogonal, but the length of the pieces make a equilateral triangle, like cutting off the corner of a cube. It's rather tricky to get everything together correctly. You could use the wrong tabs, the wrong slots. You could have a piece go in from the wrong side or upside down. You can make a mirror image. So I went around and just carefully checked that everything was properly assembled before we put the pins in that lock everything together. So these are little stainless steel pins. There are 300 of them altogether. They slide into the holes that lock the mortise and tenon together, and then they just need a slight bend that keeps them from falling out. Then we went on to the next step. There's another set of pieces that also make a triangle. This shape has a right angle in it, kind of an L-shaped piece, but they have the same idea that they're really like the corners of a cube that's been cut off, so that you have 3 planes, each is orthogonal to the other 2, that form a triangle in the shape, even though they're made of 90-degree joints. What's especially tricky is that this next set of 3 pieces has to weave through the first set of 3 pieces. These triangles go through each other. They end up making 2 overlapping triangles, something like a Star of David, but they're not exactly opposite each other. They're not 60 degrees or 180 degrees apart. Getting these 3 in the proper places with the right weave was probably the trickiest part of this construction. Once you have them there, then they slide in, the tabs go into the slots to give us this orthogonal set of planes that makes a triangle. And again, locking everything with the pins was the key idea that holds us together, that enabled us to do this pretty quickly. The pins are a fast way to join things. In some places, instead of a pin, I put a piece of a chain. The overall sculpture is suspended from 5 different points, and so there's 5 places where instead of a pin we put a little chain connector in there to hold the weight, distribute the weight. So lots of different groups did this construction, this module. There's 20 of these modules altogether that make a structure like an icosahedron. Each one is triangular, and they're going to join 5 at a point to make the overall sculpture. The next step involves a third shape of piece, 60 of these as well. And 3 of these go together on the outside to lock those 2 triangles together in the correct relative angle, one to the other. This shape is kind of curved like a comet. There's a ball at the end, and it connects to the ends of the other shapes of pieces. What's a little bit tricky here is that we only wanted to join the back part, not the front near the round by the circle. We left the front open because to join these modules together, they have to link through each other. They kind of intertwine in a complex way. So we need the front open so that we could pass them through their neighbors and then close that as a later step. So here we're taking 2 of the triangle modules, we're putting them adjacent, linked them through each other, and connected them. We did this for the first 5 modules that all have the chain on it, and together they make a cap of 5 that's like the 5 triangles at one vertex of an icosahedron. The chains from these 5 points join together, and they link to one welded ring here which carries the whole weight of the whole sculpture. Next, we suspended these 5 modules so we can add the remaining modules to them. This lobby has a balcony all around it, which is nice, gives a nice vantage point for viewing the sculpture. It also made it easy to throw a rope over the balcony and for us to work downstairs at a convenient height for assembling the modules. So this is the top 5. There's going to be an equator of 10 that goes around there, and then another cap on the bottom of 5 that looks like the 5 at the top. I was able to stand in the middle and have people working around on all different sides, adding modules to all different parts at once, and I can sort of aim the pieces and help people get them connected. They would take care of the details and add the pins. You may not be familiar with the term spaghetti code. It's computer science jargon for software which is poorly written, a terrible mess to follow and understand. But in fact, the sculpture spaghetti code is highly organized and very carefully designed so everything fits together very precisely, very perfectly. That's part of the beauty of using laser cutting to make these materials, that the laser cutting is extremely accurate so that the parts fit together quite precisely. And we found that everything went together without any trouble, without any difficulty. Now here comes the very last module. 19 have been assembled, and this is the 20th. It has to plug the remaining triangular hole in the overall structure. It occurred to me that maybe I should not stand inside anymore. So this piece went in, was connected on all sides, and a final set of pins finished the sculpture. One of the reasons why it went together so well is that I had practiced ahead of time with a half-scale model made of laser-cut plywood. So after putting in the final pins, it was finished, and we had a little party. This was an opportunity to look at it close-up before it was lifted up to the ceiling, and to think about the geometry. 180 pieces, 60 in each of 3 different shapes, and 300 pins that lock it all together. Besides the wooden model, I had also made a small 3D printed model. This is just a 3-inch model by selective laser sintering, which was designed to show people the idea, to give them a sense of the geometry so they could visualize what it would look like, just as a way to sell the concept. Lifting it up to the top of this 2-story atrium was the next step. This was the riskiest part because there was a chance for it to get banged around or dropped. A couple of weeks earlier, an eye bolt had been installed in the beam, and now all we had to do was lift up the sculpture and suspend it from a chain from this bolt. The difficulty is that the sculpture is so large that it's difficult to get above it to make the connection when you're in a lift that comes up from the ground. We carried it. It's about 70 pounds, brought it to the spot and connected it with a rope so that it could be hoisted up. This is a good chance to look at it one last time close up and think about all those right angles. Again, it does not look like it's made of right angles, and the interesting mathematical exercise for me was to come up with a design that had as many right angles as possible because of this limitation of the laser cutting that one piece goes orthogonally into the slot of another piece. Everything went according to plan. Took a little work, but there was no real problem getting it up there and getting everything connected. If you happen to be at Stony Brook University, I hope you get a chance to see it. You'll find it hanging in the Computer Science Building lobby. The very last thing I did was to go up and sign it. And finally, I'd like to thank the many people who helped me on this day of assembly, and many others who helped in preparatory aspects of creating this sculpture, Spaghetti Code.